So let me briefly go over a few of these exercises for you in case you had any struggles. First of all, when I'm talking about adding or subtracting 1, and there are things that we're doing in calculus where we will frequently be adding or subtracting 1 to some numbers, which are sometimes fractions. So luckily the value of 1 comes in many, many forms, right? Like 3 over 3 is 1. 5 over 5 is 1. Okay, so anytime we are adding fractions, we have to have a common denominator. Okay, so we're doing this, right? Adding 1 with the common denominator, following our rules with positives and negatives, and getting 2/3. Okay, probably you didn't have much trouble in this first line. Okay, down onto the second line, subtracting 1, right? Like maybe right here, subtract 4 over 4. Again, be careful of the positives and negatives, right? So now we have 4, or 3, I'm sorry, take away 4, right? That leaves me with -1, right? So you add or subtract the numerators and the denominator always stays the same. Be careful down here in these negatives, and this is where perhaps reviewing the integers remediation would have been good for you, because in this problem I have to compute -1 minus 3 and without a calculator again, and that is probably one of the most missed problems. I often will see either 2 or -2 as the answer here. But remember, if we have a loss of 1 and then we lose 3 more, right? If we look on the number line at -1, and then we're at -1 on the number line, and then we go back 3, we're going back this way, -2, -3, -4 on the number line. So I call these problems the going more into debt problems. If I had a loss of 1 and then I lost 3 more, I would have a loss of 4. Okay, so really make sure you can get these right, and then that'll help you know that you at least have the basic integer skills you need to have. So again, down here, anytime we add fractions, have to have a common denominator. So I'll do one of them with you. I'm going to multiply here by 2 over 2, right, to give me 2x over 6, right, plus the 5x over 6. And again, for adding fractions, you know, the mistakes that I sometimes see is students will say that's 7x over 12. Remember, we add the numerator, keep the denominator the same. Okay, so for adding and subtracting, we must have a common denominator. For multiplying, we never need a common denominator. There's a common theme that if we add or subtract anything, we have to have like terms or like units. And then to multiply, we never need like units. I'm going to talk a little bit about that in class because it applies, you know, we'll see that a lot in algebra, right? Where you can only add like terms like 2x and 5x, right? I can add those because they're like terms. I could not add 2y plus 5x, right? Because they're not like terms, although I could multiply, right? If I changed this to a multiply problem, I actually can multiply when I don't have like terms. So if I'm changing this to, that's a parenthesis, that would become 10xy. Okay, so I never need like terms to multiply. I always need like terms to add. So same goes with fractions. Don't need like terms. So what I do with fractions is I multiply across the top and across the bottom. Okay, so this would give me 21 over 40. Reduce it if you can, which that does not reduce. And over here, I think the most common mistake I see when students have to multiply a fraction like this is they multiply the 3 with both the numerator and the denominator, right? So they would call this 9/15. They'd multiply the 3 here as well. You have to remember this is 3 over 1, right? 5 over 1, okay? And then we apply our rule of multiply across the top and across the bottom. And pretty much we're going to be leaving our answers as improper fractions. Okay, so you certainly could turn this into a mixed number of 1 3/7, but, or, yeah, 1 3/7. But for the work that we're doing in class, mostly we will just be leaving improper fractions. Coming down to the division, all right? So if you can multiply, I think you can do this one where you just have to distribute, right? We know the distributive property. Down here under division, remember that this bar here in the middle is a division sign. Okay, so we could rewrite each of these as, 1 divided by 1/4. Okay, 2/3 divided by 7/8. And this is x over 8 divided by x. So let's call it x over 1. Okay, and then you probably remember the rule from that your high school or middle school probably teacher would have given you: copy, change, flip. That sounds familiar. Copy, change, flip for multiplication or for division. Okay, so we recopy the first fraction. Let's see, I'm going to have to move down a little bit here. Recopy the first fraction, right? Change the operation sign to multiplication and flip the second, okay, to get 4. And again, if we do 1 over something, 1 divided by anything means give the reciprocal, right? So 1 divided by, say, 2/3, right? We should quickly know, oh, 1 over something is the reciprocal, 3/2. Okay. So I think once you recall this rule, I don't think I need to work all of these out with you, but this next one, let's do x over 8 times, and actually I should be using the dot for times so that we don't confuse it with the x in the problem. And then certainly we can divide these. X over x can divide to 1, and so we would be left with 1/8 here. Okay, thanks for watching.